this to solve for y, we would say, well, go ahead and solve when x equals 3. Then you would take 3, substitute it back in for x, and you would get y equals 3 plus 2, which equals 5. Well, in Algebra 2 and us mathematicians, we don't like to write English because we hate it, right? So we came up with something called function notation. Instead of the y, we would put the f of x equals x plus 2. Then we would say, instead of writing solve when x equals 3, we would say, well, what's the f of 3? Then you would substitute in 3 for x and solve, and you get the same answer without writing any English whatsoever, correct? Do you remember? Function notation? Way back when you were little kids taking Algebra 1? Back in middle school? All right, well, we're going to do the same thing with piecewise functions. We're going to evaluate the expressions, actually their equations, but this time, we're going to put some domain restrictions on them. Okay, for example, for any numbers that are less than or equal to 4, we use 3x minus 1. For any numbers greater than 4, we're going to use 2x plus 7. Quiet. Quiet. Okay, so we're going to look for, we have to solve for the f of 10. 10, remember, is what equals x. So we go back up here, look at our domain restrictions. Which one of these expressions are we going to use for x equals greater than 10? The bottom one, the 2x plus 7. Then we're going to substitute in 10 for x. I get 2 times 10 plus 7, which equals 27. So the f of 10 equals 27. What about the f of 4? Which algebraic expression am I going to use? See, 10, x is 4. So I have 3 times 4 minus 1. 12 minus 1, 11. You should write it f of 4 equals 11, but for this course, I'm not going to require it. For your next course, you have to, otherwise it will be marked wrong. Okay? I would get in the habit if you're going to go on to mathematics, yes. Okay, number 3, the f of negative 2. Which one of these am I going to use? (3x minus 1). Because negative 2 is less than or equal to 4. So I use this expression. So for x, I'm going to put in negative 2. So I get 3 times negative 2 is negative 6 minus 1 is negative 7. What about the f of 5 halves? Which one am I going to use? 3x minus 1. Put in 5/2 for x. Okay, oh my gosh, I have to multiply and subtract fractions. Let's see, that would be 6, be 15/2 minus 1/2 is 13/2. With me? Selfish, shut up. Okay, next set of problems. You notice we have not one, not two, but three different pieces of functions or piecewise functions. Now, one equals 2/2. So, guys, if you don't stop, I'm going to kick you out. Stop. I had to put I needed a common denominator, so I changed 1 to 2/2. And then I got 15/2 minus 2/2, 13. Friday. I changed it to Friday. I wanted to put piecewise functions on there, so I just changed it to Friday. All right. Numbers 1 through 4 have to deal with the f function. Problems 5 through 8 have to deal with the g function. And problems 9 through 12 deal with the h function. All right. Number 1, starting with the f of 2. Looking at the f function, 2 is greater than 0. So the value of f of 2 is 2. Nothing to solve here. What's the f of -4? What is it? 3. What's the f of 0? 3. What's the f of 1/2? 2. Okay, g of 7. Which one do I use? 2x minus 1. Plug in 7 for x. 2 times 7? Minus 1. How about the g of 0? Which one do I use? Careful, it's less than or equal to 3. 0 is less than. So you got to use x plus 5. Good, Kristen. So I replace x with 0. 0 plus 5. How about the g of -1? Which one do I use? And substitute in -1 for x. Good. And the g of 3? X plus 5 because of the equal sign. Plug in 3 for x. 8. So far, so good. Not that hard, right? All right, h of -4. Which one do I use? Looking at the h functions now. 1/2 x minus 4. We're going to plug in -4 for x. Half of -4 is -2. Good. How about h of -2? Half x minus 4. Going to substitute in -2 for x. half of negative 2 minus 4. H of negative 1. Plug in negative 1 for x. So 3 minus 2 times negative 1. So it'd be plus 2, which gives me. And then h of 6, which one do I use? Plug in 6 for x, which is easy. Let's do something funner. Funner than just solving. Let's graph them. Yay. Yay. All right. Don't forget this is our domain restrictions, right? Anybody happen to know what happens at our domain restrictions? In this case, the number 1. There's actually an asymptote there. There's a boundary line, right? Not so much an asymptote, a boundary line. At x equal 1. Hey, you ready for the fun stuff? These are both. What kind of graphs are these? Come on. Y equals mx plus b. Yeah, a line. Big doofus. Okay, so what do I need to graph a line? 2 points. I'm going to get myself 2 points. All right. What? Not you, the other doofuses. Which point do you think I should pick always? How about the boundary point there? 1. Okay. Remember, I choose x, I have to solve for y. Okay, so I put in 2, I chose 1 minus 1. What does that equal? Happens to equal 1 this time. Now I need a number less than the number 1. This time 0 will work. Plug in 0 for x. 2 times 0 minus 1 equals negative 1. Look at that, I have 2 points. So I have 1, 1, and 0, negative 1. 2 points. I'm going to graph my line. Now, do I have an open or closed circle, do you think, at the point 1, 1? At this point, looking at my restriction, do you think I have an open circle or a closed circle? Closed, because of the equal sign. So I'm going to make sure that the teacher sees that I know that he knows that's a closed circle. Okay, now we get to graph the other one. Which points am I going to use? Yeah, but I got to choose. I need 2 points. Yeah, definitely going to use 1. So 3 times 1 plus 1 is 4. Now I need another point that's greater than 1. 2 works. 3 times 2 is plus 1. So I have 1, 4. and 2, 7. There's my line. Now, at this point, at the 1, 1 comma 4, do I have an open circle or a closed circle? Open. Because there's no equal sign in my inequality. And I'm done. This is really one of the harder things for students to get for some reason. I'm not sure why. Okay. I picked the number 1 for both. Okay, so both of them are going to have a 1 comma something. Okay, so this one had a 1 comma 4 for 3x. This line is y equals 3x plus 1. This line is the equation. Yeah. Do you see how I have a equal sign with the inequality in this one? See, that's why I got a closed circle. You see no equal sign with this one? That's why I start with it. All right, I've stopped. Well, you guys are worse than my Algebra 1 class. You really are. Algebra 1 are delinquents that come from, you know, 10 o'clock. Let's do number 14. Okay, what's my, yes, sir. Yeah, but I want to know where it is on that boundary line. That's why I always pick for my first point whatever x is for that boundary line. It may not include it. It doesn't include it, but I want to know where it's at with the open circle. If it had the equal sign, then I would close that circle and include it. But because it doesn't include it, it doesn't have that equal sign there at 1, 4. That's why I put the open circle there. Okay. Good question. Let's do another one. 14. By the way, this would really help if you have colored pens and markers and highlighters. All right. Where's my boundary line? Right. X equal 1. Same one. So there's my boundary line. Let's make a chart for the top one. I'm always going to choose my boundary line x, which is, stop it, 1. So I have 1/2 times 1, which is 1/2. Now I need a number smaller than 1. -1 will work, 0 will work, but I'm going to choose -2. Because when I go to multiply 1/2 by -2, what do I get? A whole number, -1. So I have 1 comma 1/2, so 1 comma 1/2. Do I have an open or closed circle? Open. And -2 comma 1. -2 comma -1. What? That's my boundary line. Yeah, that's my x equal 1. See how it says use this expression 1/2 x if x is less than 1. So this is x equal 1. So I know that something's happening around x equal 1 line. Well, that's just the function notation for y. Okay. All right, let's do the other one. Let's get a chart for this guy. I'm going to use the point. I'm going to choose 1 for x. So I have negative 1 plus 3 gives me positive 2. Now I need a number greater than 1. 3. Negative 3 plus 3, 0. So I have 1 comma 2. Do I have a closed circle or open circle here? At 1 comma 2. Closed because of the equal sign. Then I have negative 3 comma I did something wrong here. Yeah, is this positive 3? So 3 comma 0. So there's my graph. Yes, sir. Yeah. Once you after you use the boundary line x, which was 1 in this case, you get to choose the next one as long as it follows the restrictions. Okay, for this one, I had to choose another number less than 1. Well, we chose negative 2. Less than 1. You choose any number as long as it's less than 1. And this one was greater than 1. Yeah, you could have chose 6. Anything that's greater than 1. Sure. All right, let's take a look at your homework sheet number 1. Okay, just to recap. Which one? If I have time, all right, let me get to. Okay, well, I wasn't going to do number 1. I was just going to do the evaluate. All right, I'll do number 2. All right, number 2 says evaluate the f of negative 1. Well, if I'm looking at negative 1, which expression do I use? Oh, I don't. No, we're doing number 2 instead. The f of negative 1. Negative 1 falls in what? X is less than or equal to 0, x is between 0 and 2, or x is greater than 2. Less than 0. So I have to use x plus 3. My x is negative 1 plus 3. So my f of x is 2. What about the number 1? It's not. It is less than 0. No, it's not. It's between. Is it between 0 and 2? Yes. So it's 3. We should graph number 2. Okay, where are my boundary lines? Yeah, x equals 0, which is the y-axis. So that's x equals 0. And we have x equal 2. This time we have 2 boundary lines. And again, it would really help to highlight those. Sophist, stop. Yes. I would. No, they're not required. Stop it. I'm going to kick you out in the hall like any second right now. I know. Get out in the hall. Okay, let's do a chart for the first one. Of my X and Y. Which one do I have to use for the first one? 0. If I plug in 0 for X, I get 0 plus 3 is, I need another number less than 0. Negative 2. Negative 2 plus 3 is 1. So there's my 2 points. I'm going to draw my line. 0, 3. Do I have an open or closed circle? It's on the boundary line, so I need an open or closed circle. Closed. Negative 2, 1. There's my first one. My second one. I need a chart for the second one. I have to use, in fact, there's 2 of them I have to use. I have to use 0, and I have to use 2. Okay, what's my Y value if it's 0? 3. What's my Y value if it's 2? 3. Okay, 0, 3 is on the boundary line. Do I have an open or closed circle? 0, it's open. Okay, at 2, 3, do I have an open or closed circle? Closed. So here's my horizontal line. And then the last one, need a T-chart for that. I have to use 2. 2 times 2 is 4, minus 1 is 3, and a number greater than 2, 3. 3 times 2 is 6, minus 1 is 5. Do I have an open or closed circle at 2, 3? Careful, there's no equal sign, so it's open. And I have 3, 5. So there's my graph for number 2. I don't think we do 4 lines in here. Okay, you should be able to finish all of worksheet 1 tonight. What? Can you talk to me? Yes, you may talk to me.